AP Chemistry. This is the answers video for the day 13-14, Unit 2, Lesson 4 and 5. So this is 2 lessons put together in one. So it's really the lessons for both Thursday and Friday, September the 16th and 17th. And you want to try to get this done by Tuesday, September 21st. Its absolute due date is that Friday, which is the 24th. Okay, the first couple of pages are just an example problem. It's explaining what's explained in the video, but I recommend that you read it. You just want to expose yourself to these ideas over and over and over again. The repetition is very important. So just read the first 2 pages. This page just kind of explains the relationship between grams and moles. And the second page here gives you an example problem. Gives you an example problem right there, and you can follow through that. Again, this example problem is similar to the ones that are done on the video. The nice thing about the videos is that I do them with animations, and you can see how they proceed step by step. All right, so now we're going to move on to the problems. I'm going to do numbers 1 through 4. I'm going to do probably almost every part of it, except maybe 1 or 2 questions, and I'll leave those for you to do. A couple of these that we did in class. Okay, so I want you to get used to this graphic organizer, and I want you to use it at first, and I'll show you how I'd like you to use it. I showed that in the day 12 video, but what we have is a chemical reaction, and that's the centerpiece of chemistry. And it tells us the relationship between number of particles. Particles is just a generic word for a molecule, an atom, an ion, anything that we're trying to put together to make new compounds. So this can be read as 2 atoms of silver, 1 molecule of H2S combined. So to produce 1 molecule of Ag2S and 1 hydrogen molecule. Of course, we've said the other way you can read it is in terms of moles. 2 moles of silver, that's 2 times 6.022 times 10 to the 23rd, plus 1 mole, 6.022 times 10 to the 23rd of H2S, will give you 1 mole of Ag2S and 1 mole of hydrogen molecules. But in general, it's a relationship. However many moles of Ag you have, you need half as many moles of H2S. Or you can say for however many moles of H2S you have, you need twice as many moles of Ag. So the number of moles can be any number you want. It just has to be a 2-to-1 relationship here. That's really the best way to think of this equation. So again, chemical equations are counting numbers of molecules. Just like my classroom example, I wanted to have a senior and 2 juniors in each group. That's all I really cared about, was the number of seniors and the number of juniors. But in my classroom example, I couldn't see the people. So I had a scale tell me how much they weighed. And I knew that the weight of a senior was 150 pounds and the weight of a junior was 100 pounds. So based on the weight, I could tell whether I had seniors or juniors in the right combination. That's what we're doing here. We can't see an atom or a molecule. It's too small. And we can't count moles, 6.022 times 10 to the 23rd. It's too big. So we got a problem on both ends. Fortunately, there's a way we can do this. And that is if we know 2 things, the mass of the substance and the substance. So if we know we have pure silver, it can't be mixed in with anything else, and we know how many grams of it we have, we can use this translator, which will get us from grams, which we can measure in the lab, into moles, which the chemical equation understands. All right, and we can do that for any of these here. So on this problem, I've already given you the molar mass conversion. So get used to that phrase, molar mass. It means moles to mass. Mass is in grams. That's measured in grams. So what you're going to do with this is just lightly draw on it and get used to using it. And eventually you want to get to where you don't need to use this anymore. You can read a question and set up these problems without using this graphic organizer. Okay, so we've already compute molar masses. That's been done for you. And in class for silver, we actually did it to 2 places after the decimal. So I'll do that here. I'll just make that little change. It's going to be is going to be 0.87. Instead of 9, it's going to be 0.87. So I'll just make that little change. That's the way we did it in class. Okay? All right, so let's get started. How many moles of H2S are required to produce 3.5 moles of Ag2S? So there's two things you're looking for here. What is the question trying to find? And what it's trying to find is a unit of measure and a substance. And those two, you almost always follow the words how many, how much. It's what you're trying to find out. It's what you don't know. So this is what we're trying to find. So what you do is you go way over to the right. You draw an underline where your final answer is going to go. And an equal sign there. And then the substance, and then the unit of measure, which is moles. You don't put an S on the end of moles even when it's plural. It's just mole, M-O-L. And it's H2S. So that's what you're looking for. What you're given to start with is whatever the number is. You have a number here, 3.5 moles of Ag2S. So I'm going to come over here. Now I'm going to leave a lot of space because you don't know always how many conversions you're going to need. So I'm going to put it over here. And that's going to be, this is what we're starting with, is the 3.5 mole of Ag2S. Okay, so what you do in the graphic organizer, very lightly, because you're going to use this over and over again about 5 or 6 times, is Ag2S is what we know, 3.5. I'm going to write that very lightly. And what we're trying to find is moles of Ag2S, I should have said. So what it is, it's in the moles row, that's inside the chemical equation, in the Ag2S column. Moles of H2S. So that's here. It's in the moles row, H2S column. So what we're trying to do is get from here to here. Now understand, the chemical reaction runs from left to right. But our math equation is going the other way, because what we know goes on the left, and what we're trying to find goes on the right. Okay? So sometimes what you know is over on this side, and what you're trying to find is on this side. Sometimes what you know is on this side, and what you're trying to find is on this side. Whatever the case is, what you know goes on the left of your math equation, and what you're trying to find goes over on the right, just like you would write any math equation. So what we need to do is get from here to here. Okay? And so the conversion when it's moles to moles is simply the coefficient and the substance. The coefficient and the substance, the only thing you have to do is add the word moles because it's in the moles row. So we're going to write the equivalency here. And we're going to write two conversions. For the first two problems, I want you to write out both the equivalency and the two conversions. That's for problems 1 and 2. After that, you don't have to do that. If you can write the equivalency, I would like you to at least write the equivalency, and then if you can do the conversions in your head, it's pretty easy to do that, pretty straightforward, then you can do that. Okay, so that's H2S for every 1 mole. Okay, so both of these are true statements. You're just one over the other, or the other one over the first one, okay? So which one? We have one box. We're going moles to moles. How did we know one box? Because it was only one conversion to get from here to here. It only takes one conversion. So which one are we going to use? I think a lot of you are starting to get the hang of this. This is on the top. We need it to disappear, and we need this to end up on the top in our final answer. So we're going to put this one on top, this one right here. Moles of Ag2S cancel with moles of Ag2S. The only unit remaining at the end is this one. That's the unit that's going to be in your final answer. That you identified that is the unit you want in your final answer. So now it's just math. 3.5 times 1 divided by 1 is 3.5. And that's your final answer. So again, it's a one-to-one relationship. That's what I'm talking about. Think of it as ratios or relationships. If this is 3.5, then this is 3.5 because it's one-to-one relationship. Okay? So that's how you do that. Let's move on. We did B in class. I'll go ahead and do it here. All right, so how many grams? First thing I want to do, though, is erase your graphic organizer. Okay, you're going to use it over and over. Write very lightly in it in pencil so that you can use it over and over again. How many grams of silver is required to produce 4.67 grams of H2. So what we're looking for is grams of silver. So we come over, we find silver, it's right here, and we go down to the grams row. So it's where the silver and the grams intersect right there. That's the question mark. That's what you're trying to find. What we start with is, at least from a math standpoint, is 4.67 grams of H2. So here's H2. Grams is in this row, so 4.67 goes down here. Okay, so now what you have to do is use this to identify the path. You cannot go from grams to grams. We don't know a relationship. If we had a conversion, an equivalency that such and such number of grams of Ag equals such and such number of grams of H2, we could go directly from here to here. We'd have what we needed. We don't have that. The only place we know a relationship between these substances in terms of the number of particles, and that's up here in the chemical equation. So what we need to do is go from, we'll draw some arrows here, go from here to here using the molar mass. That's your first equivalency that you're going to turn into two conversion factors. Then we go from, that'll put us in this box right here. Then we go across moles to moles. So the relationship between moles of H2 and moles of silver, Ag. That's the second conversion. That'll put you in this box right here. And then finally we use the molar mass of silver, this right here, to come out from moles of silver to grams. So it's a 3 conversion problem. So I'm going to go ahead and I'm going to write this here. And I'm going to zoom in a little. Well, once I get the equation, I will. So I'm going to put, this is 3 conversions. I'm going to put that 4.67 way over on the left here. So 4. Okay, this is what I'm looking for. That's our question mark. And this is what I'm starting with. And we see it's going to be 1, 2, 3 conversions. So I'm going to draw the boxes. Some people draw parentheses. Some people draw nothing. But I want to make this as visual as possible. Okay. So our first conversion is going to be the molar mass. There it is right there. So I'm not going to rewrite it again. I'm just going to go ahead and write the conversion, the conversion factors or the ratios, okay? The only thing you have to add is the substance. 1 mole H2 equals 2.02 grams H2. You have to add that. So here we go. Again, it's this one over this one, or this one over this one. You just flip it. Very simple. Okay, so which one of these two goes in this box right here? Think about it. Pause if you need to pause and think about it. But always try to think through these problems on your own. Okay, we need grams of H2 to cancel out here. So that means we need it down on the bottom here so it'll cancel out. So we're going to put this first one there. So grams of H2 cancels with grams of H2. So where we're sitting is in moles of H2, which is that box right there. That's moles of H2. So we got to the first box. Okay, now we're going to get over to the second box here. So the conversion equivalency is going to be 1 mole of H2 equals 2 moles of Ag. Okay, it's a 2-to-1 relationship. So again, I'm going to, since you can see the equivalency there, all you have to do is put an equal sign between those two. I'm going to write the 2 conversions. Draw a line right here. Doesn't matter which order you do them in. Okay, so you got to pick one of those 2. One of those 2 to go in this box right here. Which one is it going to be? You need moles of H2 to cancel out because it's not in your final answer. So that means you need moles of H2 down here. So that's going to be this first one right here. Okay, so moles of H2 cancels with moles of H2. And now the only unit you have left at this point is moles of Ag, which is this box right here. That's where you're sitting. You're sitting in this box right here. Now you need to make your third conversion to get out to the question mark. That's with the equivalency of the molar mass. So again, there's the equivalency. So I'm just going to write the conversions. Okay, so remember molar masses are always in terms of 1 mole equals some number of grams. Don't let the 2 up here confuse you. That was for this relationship, that second relationship, that moles to moles. You don't include it here. Here it's always 1 mole equals some number of grams for a molar mass conversion. Okay, so I got a little tight writing here, but which one do you use? Which one of these goes up here? Think about it. You have moles of Ag up here, so you need it down here to make it cancel. And you need grams of Ag on the top to be in your final answer. So it's going to be the second one over here. So moles of Ag cancels there, and the last man standing is grams of Ag. So now that you've set up the units and the units cancel properly, now you're ready to go ahead and do the math. As far as I'm concerned, if you don't want to do the math, I think you should practice it just to be sure you make mistakes. But I'm not interested in the answer. I'm interested in this. This is it, okay? This is it. Again, once we get past the second problem, I won't make you write out all the conversion factors, but for the first 2 problems, I want you to do that. Then as you get more advanced at this, you start to get it. You can shortcut things, but I want to see all of your work on this, okay? I know there's a little bit of a tight space. You saw I had to write kind of small to do this. Okay, so let's do the calculation. Okay, so it's everything on top multiplied. Multiply everything on top. 4.67 times 1 times 2 times 107.87 divided by 2.02 divided by 1 divided by 1, and I get 503. I'm just going to go, this is 4 significant figures, I'm going to go 0.8. Okay, we should only have 3 significant figures because of that, but that's okay, we'll just go to that, all right? Okay, let's go on to the next one. All right, how many grams of H2S? So this is the what are we looking for? Grams of H2S is required to produce 8.3 grams of Ag2S. This is what we're given. What we're given goes over on the left. And now you're starting to probably see the pattern that if it's grams to grams, you're going to need 3 conversions. We'll go up to the organizer and check that out. So it's going to be 8.3. Okay. That's what you're trying to find. Goes on the right, which you know goes on the left. So let's go up here. Let's erase our last problem. Again, write very lightly, and then the erasing goes a lot quicker. Okay, so we start with grams, 8.3 grams of Ag2S. So here it is. Here's Ag2S, and here's the grams row. So it's 8.3. And we're trying to end up with grams of H2S. That's here, H2S and grams question mark. So again, even though the chemical equation is moving from left to right like that, our math equation is going to move in this direction. Okay, it's got to move back to the left. Okay, just what you start with, what you end up with. Okay, so 3 conversions. Here they are. You cannot jump from here to here. Life would be easy if you could, but you can't do that. So you got to come up through the molar mass for Ag2S. There it is. That's your first equivalency. Then it's moles to moles over here to get back to H2S. Then once you're sitting in this box, you get out to your question mark, your final answer, by using the molar mass of H2S. Okay. So let's go ahead and draw our 3 boxes. All right, so our first conversion's got to be from here to get us into the chemical equation. There is the equivalency. Again, the only thing you have to add is the substance, Ag2S. So 1 mole Ag2S equals 247.87 grams Ag2S. So we're going to write the 2 conversion factors down below. Okay, there's your 2 options. Which one goes here? Think about it. Okay, start to really nail this down by now, right? Which one? You have Ag2S up here. It doesn't appear in your final answer. That means it has to cancel out. So you pick the one that has Ag2S, grams of Ag2S, I should have said, up here. So you have to have grams of Ag2S down here. So that would be this one right here. So grams of Ag2S cancels with grams of Ag2S. So now you have moles of Ag2S. So that means you're in this box right here, in the moles box under Ag2S. You're sitting right there right now. And you don't have to do these intermediate calculations, that the way I did on the video. I did that on the video just for show, but you don't have to do that. Okay, now we need to get from this box to this box. Well, that's a pretty easy one. 1 mole of H2S equals 1 mole of Ag2S. That's just that simple. That's your equivalency. And all you have to do is literally just draw an equal sign in between these two. This equals this. The only thing you have to add is the word moles to it when you do the conversion factors. Okay, so we'll go down and do that. Okay, so now you choose one of those to go there. Which one is it going to be? You need Ag2S to cancel out. So moles of Ag2S, let me be clear on that. Moles of Ag2S to cancel out. So it's got to be the one with moles of Ag2S on the bottom. That's this one. Moles of Ag2S cancels with moles of Ag2S. Now you have moles of H2S. That's where you are right now. So that's right here in the moles row under H2S. So you're sitting in this box right here. And now you need to get out. There's your equivalency, the molar mass of 1 mole of H2S. All you have to do is add the H2S to this, and that's your equivalency. So we'll go ahead and write the conversions for that. So there's your two conversion factors right there. Which one goes in here? So this time you have two reasons to pick it. It's going to be this one. You need moles of H2S on the bottom here to cancel, and you need grams of H2S to appear on the top so that it's in your final answer. Okay, moles of H2S cancels with moles of H2S. Grams of H2S is the only unit left, and that's in your final answer. That's what you want. So that means you set your numbers up correctly. Okay, so now what you can do is multiply everything on the top, 8.3 times 1 times 1 times 34.09 divided by, you don't even have to hit the equal sign, 247.87 divided by 1, and that gives us 1.14. Should be two significant figures, so 1.1, but I'll go ahead and put this so you can just confirm that you got the right number. Okay, all right, so that's your answer for that. Okay, I don't recall if we did D or not in class, but it's boldface. Those generally are the ones that I leave for you to do. So I'm going to come on down and do E and F. I'm going to do them a little bit quicker. Okay, so how many grams of H2 will be produced by 5.67 moles of Ag? So we're dealing with the same equation. So grams, so what you're looking for is grams of H2. So we can go ahead and write that over here right away. Some number grams of H2. And we start with this, a number, 5.67 moles of Ag. So I'm going to start way over here, because I may not know at this point how many conversions I'm going to need. So I'm going to leave a lot of space. Okay, so let's go to our organizer. So 5.67 moles of Ag. So here's Ag. Here's moles, so that's where the 5.67, that's our known value, what we're starting with. And we're trying to get to grams of H2. So here's H2, and you come down to the grams row, and you put a question mark. So how many conversions is that? You can only go sideways inside the chemical equation. So you're going to go from moles of Ag to moles of H2. And then from moles of H2, you're going to come out using the molar mass to get that. So that's a 2 conversion problem. Recall what we said in class. You cannot take an alternate route. You cannot go from here, use the molar mass, and get grams of Ag. You can do that, but it doesn't do you any good. Because grams of Ag to grams of H2, we have no relationship between grams of Ag and grams of H2. So any sideways movement has to be done inside the chemical equation, where we have the chemical equation to give us relationships between these. All right, so we're going to go from here to here. And that's going to be just simply 2 mole Ag equals 1 mole H2. The chemical equation basically gives you your equivalency right there. You just have to add the word mole to it when you do it, okay? So I'm going to go down and write the 2 conversions for that. Okay, there they are. Let's go ahead and draw our boxes. We said 2 conversions. That means 2 boxes. Okay, so which one of these 2 goes up here? You got to get moles of Ag to cancel because it doesn't appear in the final answer, so that's going to be this one. It has to be on the bottom. Okay, moles of Ag cancels. So now you're sitting in the moles of H2 box right here. Now we use this, our molar mass, to get out. So that's your equivalency. You just have to add the substance. 1 mole H2 equals 2.02 grams of H2. So we'll write the 2 conversions for that. Okay, which one do you want to put here? Again, you got 2 reasons to pick one of them. Which one are you going to pick? You're going to pick this one. You need moles of H2 on the bottom, and you need grams of H2 to appear in the top for your final answer. Okay, moles of H2, grams of H2, bam, goes over there. That's your final unit. So now you multiply everything on the top, divide by everything on the bottom. And I get 5.72. And we can go to 3 significant figures. And that is your answer for that. Okay, last part of the first problem. How many moles of H2S? So this is what you're looking for, moles of H2S. We can come over and write that right away. Are needed to produce 6.8 grams of Ag2S. So way over here, we're going to put 6.8. Okay, let's see how many conversions we need. So we're going to start off with 6.8 grams of Ag2S. Here's Ag2S. Here's the grams row, so 6.8 goes there. And we're trying to find moles of H2S. So here's H2S. Here's moles right here. That's where the question mark goes. So we need to get from here to here. So you come first up into the equation using the molar mass of Ag2S, and then you simply have just a simple jump from here to here using this equivalency right here. 1 H2S equals 1 mole H2S equals 1 mole Ag2S. Okay? And that'll get you your answer. All right, so let's go ahead and do that. It's a 2 conversion problem. Okay, so our conversions for Ag2S molar mass. Okay, there's your 2 choices. Which one goes in the first box? Grams of Ag2S has to cancel out. So this one has grams of Ag2S in the bottom, so you're going to choose this one. Okay, grams of Ag2S cancels there and there. You have moles of Ag2S. So you're sitting in this box right here in the moles row under Ag2S. You're right there. Now you need to jump from here to here. Very simple relationship there. I'll write it down here since I have more space. Okay, there's your 2 choices. Which one goes here? Again, you have 2 reasons to choose the correct one. So we're going to go with, we need moles of Ag2S to cancel out, and we need moles of H2S to be on the top for the final answer, so it's going to be this one. Cancel that, cancel that. There's the last man standing is moles of H2S. So it's simply 6.8 times 1 divided by 247.87 divided by 1. Of course, you know you can not do all those ones, but just remember that you do have to do everything on the top normally. 6.8 divided by 247. And that gives us 0.027. Significant figures would be 0.03 because of the 6.8 limits, but we'll go ahead and put that, okay? All right, that takes care of it. So fairly long, about 40 minutes just to do one problem. That's why this is a 2-day assignment plus the weekend. I'm going to do almost every problem on these 4 problems that I'm asking you to do. Again, the 5th one is optional. And if you don't get this after 4 problems, then come in with me with that problem blank, number 5, and we'll work that together. Okay, so I'm going to continue these answers. on the next video. We'll see you then.